let's interact with our SR flip-flop. So the first thing we notice is we've got some errors here, and interestingly enough, if you look at the user's guide and type in shortcomings, he actually talks a little bit about some of the timing errors associated with things like SR latches. And so it's actually a little bit of a problem with the software that he hasn't fully addressed. So I'm using an SR latch that I made as kind of a submodule to make the SR flip-flop. And so if you wanted to do like a real bigger simulation, you'd probably use these built-in flip-flops that he's got that work a little bit better. The real problem is these NOR gates that depend on each other. Anyway, so we can still actually kind of get around that, right? We can go to our booger picker finger here and do a little simulation, and if I just reset this guy, okay, I would just kind of click it around until I got some values there. So now we're good to actually play with this. Now you see, if I adjust this S and R, it doesn't change anything, and that's not too different, right? It's just kind of like a normal latch. But when clock goes high, I can either set the output or reset. But when I say output, I really mean this internal output of the master. The slave still doesn't change, right? Because the slave is seeing a 0 for its clock signal because of this inverter. So I can set and reset it. But what I really need to do, so right now we've got a state of 0. So we'll set it. What I really need to do is have the clock also go low, so this set signal can write the slave. And there we go. Now we've written the slave, and once again I'm in this point where I can change those around as much as I want, and the slave still isn't going to get written until the clock goes low again. So it has to go high and then low in order for a write, which is a pulsed signal.